So we looked at how to apply sine law. We looked at ambiguous cases to see when you can have one or more than one or no solution. Then we looked at a word problem. And now here's an impossible case. So if you have a triangle where no angles are given, where only the sides are given, it is impossible to solve using sine law. Because if you look at it, our whole setup depended on us knowing at least 3 out of 4 unknowns. If I only know these 3, it's not possible to find the other 3. Because any pair of equation you take, you're going to have 2 things known and 2 things unknown. So we use another law which is called the law of cosines. So it's complementary to law of sines. Again, we start with any triangle. We label it appropriately, meaning ABC, ABC. Then we have this relationship. A squared is b squared plus c squared minus 2bc cosine a. Now it's kind of symmetric. When you write the expression for a squared, you only use b and c, and then you use a in the angle. Similarly, writing the expression for b squared, you write b in the angle, but you only talk about a and c. You write c in the angle, and you only talk about a and b. It looks similar to Pythagoras theorem, because if I remove this part, that's sort of like a Pythagoras theorem subtracting some stuff. Let's look at an application of this. Find the length AB. Now, first of all, why can we not use sine law? Let's label this as C, this is B, and this is A. If I want to use this, I should be using C over sine C equals B over sine B, or C over sine C equals A over sine A. In here, I know angle C, I know side B. Not possible, because 2 unknowns. Over here again, I know angle C, I know A, and again, not possible. And that's because knowing one angle tells me nothing about the other 2 angles. So instead, we're just going to use this cosine rule. So C squared. So when you deal with C, all the algebraic terms are going to be B and A, but the angle is going to be C. So just go ahead and plug these numbers. B squared is 388 squared plus 212 squared minus 2 times 388 times 212 times cosine of 82.4. Now remember, this is a big number, and that's because that is C squared, right? So just like Pythagoras theorem, to get the value for C, you're going to have to take the square root. So after you evaluate it, you can just press square root and the answer button to get 416.81. And since it's a length, that's the only answer you have. Now the next example is the typical scenario that we use to introduce cosine law. The one that was impossible to solve using sine law, where 3 sides are given and you have to find the angle. So let's start with any relation. A square is b square plus c square minus 2bc cosine A. Let's solve for cosine A. That would mean subtract from both sides to get a squared minus b squared minus c squared is negative 2bc cosine A. Once again, our goal is to solve for cosine A, so we divide both sides by negative 2bc to get a squared minus b squared minus c squared over negative 2bc is cosine A. Once we can get cosine A, we know we can use inverse to get A. And we can do this because we have all three sides. So let's just go ahead and plug this. 5 squared minus 8 squared minus 12 squared divided by negative 2 divided by b, which is 8, divided by 12, 0.95, which is acceptable because it's less than 1. Cosine inverse would give me roughly 17.61 degrees. Now from here on, you have a bunch of pathways that you can take. You can use expression for b squared to find angle B, but you can also be a little smart about it, and now you can use sine law. From here, you proceed here, and now you can say, well, a over sine A is going to equal b over sine B, because that's true for any triangle, which means a sine B equals b sine A, which then means sine B is b times sine A over A, as you've done many times before. And now you plug in 8 times sine of the angle you just found, which is 17.61, divide by A, which is 5. So you get 0.484, which means you can find angle B just by taking the sine inverse of the answer you obtained. So B comes out to 28.95 degrees. And then once again, you can use cosine law or you can use sine law to find C, but easier, quicker way, smarter way to do this is now to notice that once you have two angles, finding the third angle, you just subtract from 180. So you get 180 subtract 28.95 subtract 17.61, 133.44 degrees. So the impossible case, which we are not able to solve with sine law, we can use cosine law once, get one angle, use that to get the second angle using sine. Once you have two angles, just use 180 minus sum of two angles to get the third. So that's a general procedure for solving when three sides are given. Let's look at one more example. So again, it says solve the triangle, but I'm just gonna do some of it. Let's say find the side. A squared is b squared plus c squared minus 2bc cosine of A. So A is going to be square root of whatever this comes out to. So really not much to do here, but plug in 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times cosine 46.5. And then we take the square root of the answer obtained, 13.12. Now from here on, how you proceed to find angle A, angle B and C really depends on you. You know A, you know angle A, you know small b, so maybe use sine law to find angle B. because if you set this up, you know this, you know this, you know this, so you can find this. Once you find B, very easy to find C, right? Because the sum is 180. In the previous problem, we obtained this expression for cosine when we were solving for angle. So that we can do that and express cosine law by solving for angles. And so if you recall, as the expression, cosine A is, all I did was multiply numerator denominator by -1 to get this. And you can fill this in for B using symmetry. So for A, it was B squared plus C squared. So for B, it's the other things, A squared plus C squared. Then A was a negative A squared, so this is negative B squared. On the bottom, you had B and C, so no A's. So here, no B's, so 2A and C. Similarly, you can use that to fill in for angle C. And symmetry argument, it should be A squared plus B squared minus C squared, 2AB. Okay, so that's just another application, or to make calculations easier, you can just use this. You don't have to remember any of this. You can derive this quite easily in like 3 steps or so. So that's going to be the end of application of cosine law. The next session we're going to take a little detour and talk about an additional property of triangle, which is areas. And that's it for this video.